Hi guys, welcome to this page of the notes, and what I want to start off with is again just emphasizing this point, and that point is that exponential and logarithmic functions are inverses, right? And inverse functions will cancel each other out when you do the composite function. So if you have the exponential function e to the x and the logarithmic function ln of x, those are inverse functions, such that if I were to do the composite functions, right, which we've done before in a previous section, you should recognize this, they're going to cancel each other out, right? Again, it's not written, but as long as the base of the logarithm and the base of the exponential are the same, right, they cancel each other out. Just real quick here, I can write one right here. If you have log base 2 of 2, right? We know that that's equal to 1 because the base of the logarithm and the base of the exponential cancel each other out, and you're left with just 1. Okay, exact same thing here. The base is e. I know ln is a base e logarithm, so the base of the logarithm and the base of the exponential are the same. They cancel each other out. I'm left with just an x. They are inverse functions. Same thing here, right? I know ln is a base e logarithm, so the base, it's not written, you need to know it's there. The base is an e, and the base of my exponential is an e. Well, the base and the exponential base cancel each other out. I'm left with just an x. They're inverse functions. They will undo each other when you do the composite function, all right? Really, really important. E and ln, they're inverse functions. They undo each other. All right, let's jump into this guy. Here's what I'm going to ask you to do. We did all of this before. Again, like I said, you'll recognize all of this math from previous sections. We're applying all the properties of exponentials and logarithms, just now doing it for the natural base e. So here we go. I want you to use the definition of the natural base to rewrite these logarithms. And I told you guys way back in section 1 here of chapter 7, the nice simple little shortcut to this is snail method. Yep, snail method. I told you snail method would be with us every single section in chapter 7, and here we go. We've seen it in every single section. So let's rewrite these guys. I have ln of 4 is equal to x. Snail method will allow me to rewrite it. The base, there it is, base, which is e. We work our way around the equal sign. Again, if you wanted to, you can finish off your little snail shell. Draw yourself a cute little snail. We like to call him Gary. He likes to meow. Anyway, it would be base e because ln is a base e logarithm. So e to the x power is equal to 4. Snail method allows me to rewrite this logarithm as an exponential. Exact same thing if I have an exponential. We're going to use the snail method. Take the base, work your way around the equal sign. So I'm going to have a log. Now careful, it's going to be a log base e. Do not write log base e. Don't write log base e, it's ln, right? Log base e means ln. In fact, let me put this right here. Really, really important. I'll write nice and big. It's going to be log base e is equal to ln. Log base e means ln. So, because I would have a log base e, I'm going to write ln instead. ln of 12 is equal to x. All right, keep going. The rest of these are snail methods. We'll do them real quick. Base e to the x equals 10. E to the x equals 10. This one's a base e, so it's going to be a logarithm base e, which is ln. ln of 8 equals x. ln of 8 is equal to x. This one, it's a base e logarithm, so base e to the x is equal to 18. E to the x is equal to 18. And this last one, e to the 5th, so it's going to become a logarithm, but base e logarithm is ln, so the ln of x is equal to 5. Right? So again, it's just the snail method. We learned way back, we've seen the snail method in every single section. Now we're just applying it to the natural base e. Works the exact same way, and again, e and ln are just inverse functions, right? They're the inverse of each other. The base e exponential and the base e logarithm, and the snail method will get you back and forth between the two. Head on over to the next page of notes. We'll look at a couple other properties of exponentials and logarithms. I'll meet you guys there.